Welcome back viewers. In today's video, we are going to check out what is Podman. So I have opened up a knowledge base resource from redhat.com. So we will now study what is Podman. So Podman, that is the Pod Manager, is an open source tool for developing, managing and running containers on your Linux systems. It was originally developed by Red Hat engineers along with the open source community. Podman manages the entire container ecosystem using the libpod library. Podman is daemonless and has an inclusive architecture which makes it more secure and accessible option for the container management, and its accompanying tools and features such as Builda and Scopio allow developers to customize their container environments to best suit their needs. And this is the link to install Podman for free with the Red Hat Enterprise Linux. So you can download a trial version of the Red Hat Enterprise Linux server, and you can install Podman on the server for free, and you can do a trial. So just I will click on this link, so you will get an idea what is there. So you can just log in, make your user ID if you don't have a user ID on the Red Hat website, and then you can download your trial. So you will get a single 60-day self-supported subscription to the Red Hat Enterprise Linux server. You will get access to the Red Hat's award-winning customer portal, including documentation, helpful videos, discussions, and more. And you will have a single entitlement to all the available versions of this product, that is the Red Hat Enterprise Linux server. And you will get access to the Red Hat Smart Management and the Red Hat Insights. And then you can go on to install the Podman on the Red Hat Enterprise Linux server, and you can learn more about the Podman. You can learn more about the containers. If you are a developer, you can check out the application development in a container and managing it with the Podman. So all these things you can try out. So we will go back to the Podman page, and there is a this video is also there. So it will be best to watch this video for the new users. So what are pods? Pods are a group of containers that run together and share the same resources. It is similar to Kubernetes pod. Podman manages these pods via a simple command line interface and the libpod library, which provides the API, that is the application programming interfaces, for managing the containers, pods, container images, and the volumes. Podman command line creates and supports the Open Container Initiative containers. So the containers used or managed by the Podman are compliant with the Open Container Initiative. So this will be another topic if you want to learn more about the Open Container Initiative, which we can do it in some later video. So we will just go with the basic introduction to the Podman. So Podman which are designed to meet the industry standards. So the Podman CLI creates and supports the Open Container Initiative containers which are designed to meet the industry standards for the container runtimes and formats. Though more advanced building capabilities are available in the complementary project Builda. So Builda is more advanced uh, tool to build container runtimes and formats. Users can run Podman on various Linux distributions such as Red Hat Linux, Fedora, CentOS, and Ubuntu. Each pod is comprised of one infra container and a number of regular containers. The infra container keeps the pod running and maintains the user namespaces, which isolate the containers from the host. The other containers each have a monitor to keep track of their processes and look out for dead containers. So dead containers are basically non-functioning containers that cannot be taken out of the environment because some of their resources are still being used. So what makes a Podman different from other container engines? So we have already checked out in the earlier video Docker. So Docker is an alternative container engine or a container manager. So now we will check out the differences between Podman and Docker in this section. So Podman stands out from other container engines because it is daemonless. So if you remember, Docker had a daemon. Podman doesn't have a daemon. So this is one of the biggest differences. Daemons are processes that run in the background of your system to do the heavy lifting of running containers without a user interface. So if you remember, the containers don't have any user interface, so you can only interact with the container using the command line interface. Or there are some GUI based interfaces, I think, for the containers, but most of the developers and the system admins prefer the command line interface. Think of daemons as the intermediary communicating between user and the container itself. So all the commands that you pass in the command line will first contact the daemons, and then the daemons will perform the actions on the containers as per the command executed in the command line interface. So it is an intermediary. While daemons can be a convenient way to manage your container environment, they can also introduce security vulnerabilities. Most daemons run with root privileges. In Linux systems, the root account acts as a super user with administrative access, while also bypassing the need for the admin verification to read files, install programs, edit applications, and more. This makes the daemons an ideal target for hackers who want to gain control of your containers and infiltrate the host system. Podman cuts out the daemon and allows regular users to run containers without interacting with the root on daemon, or allows the use of rootless containers. So this is more advanced knowledge in the containers. So there are this is a new kind of containers we are coming up, that is the rootless containers. By going rootless, users can create, run, and manage containers without requiring the processes with admin privileges, making your container environment more accessible while reducing the security risk. Additionally, Podman launches each container with a security enhanced Linux, that is SC Linux label, giving administrators more control over what resources and capabilities are provided to the container processes. So individual container processes can be administered using the SC Linux. So the resources capabilities can be managed using the SC Linux in Podman. Now the question comes, how does Podman manage containers? So users can invoke Podman from the command line to pull containers from a repository and run them. Podman calls the configured container runtime to create the running container. So what it will do, it will pick up the configure container runtime to create the running container. So there will be a pre-configured container configuration. It will pick up the configuration from the registry and it will run in the given container. It will run the process, the application, whatever it is inside the running container. But without a dedicated daemon, Podman uses systemd, a system and service manager for Linux operating systems to make updates and keep containers running in the background. By integrating systemd and Podman, you can generate control units for all your containers and run them with the systemd automatically enabled. Users can manage their own repositories on the system as well as the systemd units to control the automatic starting and management of their own containers. Allowing the users to manage their own resources and their containers running rootlessly discourage the poor practice of making /var/lib/containers world writable or any system management practices that might expose application to the additional security issues. So what it is doing is it is using the systemd. If you remember, all many of you might be knowing the systemd is a daemon that is used to manage a Linux distro. In most of the Linux distros, you will find systemd. It is used to manage the whole system. So that is used along with the Podman to manage your containers in a Red Hat Linux server. So you can use the system SC Linux and Podman. All the three will be used to give a secure container. So that secure container is very difficult to hack by the hackers, and you get the best system management practices implemented using the three of them. So your containers are the most secure. And this also ensures that every user has a separate set of containers and images and can use Podman concurrently on the same host without interfering with each other. When the users finished with their work, they can push changes to a common registry to share their image with others. So basically what happens is multiple users can create, run containers, and those containers will not interfere with each other. Their processes will remain separate. Once their work, say for example, application development is going, two developers are doing concurrent application development in two different containers. Once they finish their work or one of them finish their work, he can publish the image to the registry. So whatever changes the application has undergone, that will be captured in the container image, and that container image can be posted to the registry. And next time when the developer will again log in, and he can just go to the registry, he can use the image that was updated earlier and he can start from there. So he can do his application development work continuously. It will be a cyclic continuous process, and till the time he is satisfied with the application development. Once he is satisfied with the application development, he will publish this application to the production server. The production server might be on a customer site or a customer server, and it becomes very easy to publish the application from your development server or the development container where the developer is working to the production server production container. So it is very easy for the developers to do the development work. It is a kind of agile software development. Now, Podman also deploys a RESTful API, REST API, to manage the containers. REST stands for Representational State Transfer. REST API is an application programming interface that conforms to the constraint of REST architectural style and allows for interaction with the RESTful web services. With the REST API, you can call Podman from platforms such as CURL, Postman, Google's Advanced REST Client, and many others. And there is a link to this 5 Podman features to try now. So we will do it in some later video. Now let us focus on Podman, Builda, and Scorpio. So Podman is a modular container engine, so it must work along with tools like Builda and Scorpio to build and move its containers. With Builda, you can build containers either from scratch or from a ready-made image as a starting point. Scorpio moves container images between different types of storage systems, allowing you to copy images between registries like docker.io, quay.io, and your internal registry or different types of storage on your local system. So it makes the Podman, this container system very portable. You can just move your images from one storage space to another storage space easily. This modular approach to containerization results in a flexible, lightweight environment by reducing overhead and then isolating the features you need to achieve your goals. Smaller, more modular tools have also evolved more quickly, and each tool can focus on a single purpose. Think of Podman, Builda, and Scorpio as a set of specialized Swiss Army knives that can be combined and can meet pretty much of the container user cases. Podman is the biggest of these knives, so it is a key knife among these three. So if you have Podman, you may use or you may not use these two tools, but Podman is essentially required for the container management. Podman and Builda use runc, that is the OCI runtime, by default to launch containers. You can build and run an image, or you can run Docker formatted images with runc. This Go language based tool reads a runtime specification, configures the Linux kernel, and eventually creates and start the container processes. With some configuration changes, you can also use Podman with your footprints like crun. So this is our more advanced. So we can go to the more advanced stages of this container management later on, some later videos. So in the next few videos, we will do some basic operations. We will build, operate the containers. We do some basic operations on the containers. So how we are going to do that? That is a secret. So in next 2-3 videos, you will know what we are going to do ahead. But try to watch the whole video. Last 4-5 videos you should watch all, because it is a sequential flow of information to you. So if you miss any of the video, you will not understand. Now, what is the difference between Podman and Docker? So Docker is a containerization technology that enables creation and use of Linux containers. The main difference between Docker and Podman is the Podman's daemonless architecture. Podman containers have always been rootless, while the Docker is recently added a rootless mode to the daemon configuration. So now Docker is trying to come up with rootless technology. So it has added a rootless mode. So thus deficiency of Docker because it had got a root daemon, so daemon with root, so that deficiency, security deficiency has been removed, and now Docker has added a rootless mode to the daemon configuration, and it is more or less equivalent to Podman in security features. It is as good as secure as a Podman. Docker is an all-in-one tool for container creation and management, while Podman and its associated tools like Builder and Scopio are more specialized for specific aspects of containerization, allowing you to customize as per your needs in your cloud native applications. Podman is a powerful alternative to Docker. The two can also work together. Users can easily switch between them by aliasing Docker to Podman. Alias is Docker is equal to Podman. So you can easily switch between these two say container engines or the container managers. So you can use this alias Docker is equal to Podman and vice versa. So if you have got a Podman, then you can use the Docker, and if you have got a Docker, you can use the Podman using this alias. How it works? So we will have to do a practical on our say virtual machine, and then we will have to check how it works. So right now, just by reading, we will not know exactly how it works, but definitely it should work. That they are given, so it is there, it is a industry practice, so we will have to check it in a practical some practical video on a virtual machine. Additionally, an RPM called Podman Docker can drop a Docker into the system application path, which calls Podman for those environments where the Docker command is needed. So you can use the Docker commands in a Podman, and maybe vice versa is also possible using the there is one RPM called Podman dash Docker. So you can do all these things in a Red Hat Linux server. So you will require maybe require a Red Hat Linux server. So that server will contain this RPM, or if it is not installed natively, we will have to install it from the software manager, that Podman dash Docker, and then you can use the Podman commands in a Docker commands in a Podman, because the system application path will be suitably modified so that you can use the Docker commands in a Podman. So this is all this feature is given. So in sometimes in industry, so when you are admin and you require to run some Docker commands in the Podman, you can easily do it. So this extra feature is provided. Podman's command line is similar to the Docker container engine, and users who are familiar with one are likely to have success with another. Some developers leverage Podman Docker together by using Docker during the development stage and transferring their program to Podman in the runtime environment to benefit from its heightened security. So if you remember, the Podman is daemonless, so it is more secure Docker, and for that reason, Docker is easy for the development stage. So they will use the Docker in the development stage, and when they want to push the application or the image to the production server, they will transfer the Docker image to the Podman using the above RPM called Podman Docker. So it will drop a Docker into the system application path of a production server which has a Podman running. So you can see both are interchangeable. You can publish images or applications from Docker to Podman, and I think vice versa is also possible. That we will have to check up whether vice versa is possible. It is not given here, but maybe it should be possible, because from Docker you can port to Podman. That is definitely possible. It is given here, and it is used by many developers. Developers prefer Docker for the application development, and they prefer Podman for the production environment. Podman is best suited for developers running containers without Kubernetes or the OpenShift container platform. CRI-O is an open source community driven container engine for Kubernetes container orchestration, such as the Red Hat OpenShift container platform. So this is another topic for another video. So we will maybe in future we will do it, but in the next few videos, as I told you earlier, we will stick with the basics of container management. Now, why the Podman? So what is the requirement for Podman? Podman changed the container landscape by offering high performance capability as a leading container engine, but with the flexibility, accessibility, and enhanced security that many development teams today are seeking. Podman can help you to manage container images and full container lifecycle, including running, networking, checkpointing, and removal. Run and isolate resources for rootless containers and pods. Support OCI and Docker images as well as Docker compatible command line interface. Create a daemonless environment, improve security and reduce idle resource consumption. Deploy a RESTful API to support Podman's advanced functionality. Implement checkpoint restore functionality for Linux containers with checkpoint restore in user space, that is CRIU. CRIU can freeze a running container and save its memory contents and state to a disk so that the containerized workloads can be restarted faster. Say for example, if your production application is running inside a container, at one point of time, suppose the application is not being utilized by the containers, then that whole container can be freezed and the image of that container will, along with the memory contents will be saved to a state onto a storage disk, and whenever the customers will like to access the application on the server, that container, the saved state of the container along with the memory contents will be again restored, and the container will immediately start to service the customers. So this is the use of the checkpoint and restore functionality for the Linux containers. Automatically update containers. Podman detects if an updated container fails to start and automatically rolls back to the last working version. This provides new levels of reliability for applications. Suppose there is some update to the container functionality or the application that is running in the container, and for some reason the this update fails, then there is a automatic rollback facility available. So the container will be automatically rolled back to the last working condition. This is all automatically detected by the Podman. The rest of the things, of course, we will not go through. This is how Red Hat can help you with the containers. It is all given, so it is all commercial data. And there is this universal base image book, so you can read this book about the container images. So that will be more advanced. So basically, we are trying to just introduce you to the containers and get you started with the containers. What are containers? We will do some basic operations on the container. We will create the containers. All those things we are going to do in all very basic way. If you want to learn, you can have another separate video or a series on a payable basis or whatever, I think. So we will just keep stick to the basics only. So I will stop the video here. See you in the next video.